3. Question number 3 is saying given below are seats owned by different political parties in a polling outcome of a state assembly election. Political party are given A, B, C, D, E, F and their seat owns given 75, 55, 37, 29, 10 and 37. What we have to do, we have to draw a bar graph to represent the polling result. So you can see I already draw the table here. Okay. For the bar diagram, you can see I told that there is two axes here and here there is two axes. Okay, so A, B, C, D, there are 6 party, and in the here what it called y-axis I draw up to from 10, 20 up to 80, because here you can see lowest is 10 and highest is 75. So I draw from 10 to 80. Okay, 10 gap. If you can draw this one in graph paper, that will be better. So this is actually, this axis is actually seat own. Okay, so first is A own 75. 75 must be 70, between the 70 and 80, that's a middle value. So I just draw like this. Okay, keep in mind all the width of the bar should be same. Next is B own 55, 55 between 50 and 60. So that is not very difficult to draw. Okay, draw the line here and just draw like this. Okay, next is 37, 37 just nearby 40. Okay, so you have to you have to keep in mind just nearby 40 like this. Then 29, 29 will be just nearby the 30. This is the 30 line, so just nearby the 30. Then 10 you can easily draw the 10 here. Okay, then 37 also same as here, you can draw like this. Okay, keep in mind the gap between them must be same. Okay, next the question is part 2, which political party have won maximum seat? So from the bar you can see political party A won the A higher, so political party A won the maximum seat, that is 75. Next question is question number 4. Question number 4 are saying that the length of 40 leaves of a plant are measured correct to 1 millimeter and the obtained data is represented in the table. So there are 40 leaves and their measure is given here. 118 to 126 3, 127 to 135 5, 136 to 144 9, like this up to 172 182 leaves. Okay, one thing you have to let's discuss this one in solution. What you have to do is draw a histogram to represent the given data. Okay, so we have to draw a histogram for this data. You can see this is continuous distribution, so we have to draw the histogram. So here I make the table, but with this part was not given in the book, so I'll explain how to do this part. One thing we have to keep in mind that for continuous distribution we'll use histogram. Okay, group distribution. For group distribution we'll use histogram, and for discrete distribution we'll use bar graph. Okay, so one thing here you can see 118 to 126, 127 to 135. What kind of group is this? This is discrete group. Okay, this tool, the upper class boundary of first class interval and lower class boundary of second interval is not same. That means it is not continuous frequency distribution, continuous group frequency distribution. So we have to make this class interval continuous. For this, what will be our process? To make discrete to continuous class, what you have to do, the difference between the upper class limit of preceding class and lower class limit of current class by 2. Okay, what that means? It's saying the difference between the preceding class, upper class boundary of preceding class, and the lower class limit of the current class. Okay, that means the difference between these two by 2. Okay, for example, you can see 127 plus 126 by 2 equal to 0. We have to find this value first. What is the difference between the upper class limit of preceding class and lower class limit of the current class by 2? Then we have to add the value, whatever value we got, we have to add the value to all the upper class. All the upper class we have to add the value, and on the lower class we have to subtract the value. Okay, so we got 0.5. we will add 0.5 all to the all upper class, and to the lower class we will subtract the 0.5. So you can see first class interval we made 117.5 to 126.5. So you can see if we subtract 0.5 from 118, we can get 117.5. Okay, and if you add 0.5 will be 126, we will get this. So our class interval is 117.5 to 126.5. This is 126.5 to 135.5. Okay, like this 135.5 to 144.5, 144.5 to 153.5, like this 171.5 to 180.5. You can see the upper class boundary and the lower class boundary of the second class is same. So this is the continuous group distribution. Okay, now number of leaves, that means the frequency are same. Okay, that does not matter, it will not affect it. Now come to our histogram. So in this histogram is same as the bar graph, but the thing is that here here it is a continuous group distribution, so the gap between the bar will not be there. Okay, so same as we will use this is x-axis, this is y-axis. Okay, we will mark few point here on the x-axis. Okay, same gap. So first is 117.5. okay, 126.5. we have to write all the lower class and the last upper class. You can see all the lower class are 117.5, 126.5, 135.5 up to 171.5, and the last upper class, that is 180.5. You can see I wrote all this 117 to 126, 135, 144, 153 up to 180.5. So and this y-axis we have to write the frequency. So here I can see lowest is 2 and highest is 12. So according to this, the gap should be between them should be the same. So I wrote 2, 4, 6, 8, 10, 12, and in between I'm putting a point to make it like 3, 4, 3, 5, 7, 9, 11 mark. And this mark is very important. What this mark mean? We know, look, this is 0. Okay, and I wrote here 117. This denote there is a big gap between them. Okay, to denote that I'm writing like this mark. Okay, so what we have to do, our first class 117.5 to 126, what is the frequency? 3. So for here we have to mark, for 117 we have to mark here 3, and here also 3. So we will draw a line here, then we'll draw the histogram. Okay, the bar same, the bar will remain same, but there will be no gap between them. Next is 126 to 135, that is 5. So on 5 I'm marking point here and point here, then I'll draw this line and then we'll join like this. Next is 135.5 to 144.5, that is 9. So 135.5 in this line I'll put a point here to 9, and here also 9 I'll put. So I'll draw this line, then I'll draw the bar like this. Next is 144.5 to 153.5, that is 12. So here 144.5 for 12, I'll put a point here, and again I'll put point here, then draw the line, join the line and draw the bar. Keep in mind there is no gap between bar. Next is 153.5 to 162.5, that is 5. So for 153.5 that will be 5, so I draw a line here according to 5. Better if you can draw in the graph paper. Okay, last is 162. Second last 162.5 to 171.5, that is 4. So on 4 I draw this line. Okay, like this, again bar, another bar. Last one 171 to 180.5, that is 2. Here also on 2 I draw this line and this. So it denotes, look, if you can read the graph, you can see for the 117.5 to 126.5, this histogram represent. Okay, that denote the 3. Look, the number of leaves here is 3 for this class. If you choose the class 153.5 to 162.5, where is 153? 153.5 to 162.5. This graph denote to 5. Okay, this is 5, so this is denote the 5. Okay, so that is the meaning of the histogram. From the graph you can check what is the frequency of the that class interval. Okay, now come to this question. Question number 2 is saying, is there any other suitable graphical representation for the same data? Look, I am giving the answer now. Later I will explain. That is frequency polygon. Okay, frequency polygon, when I was discussing the values, I mean the term, I told that frequency polygon is same as histogram, but there we used to consider the class mark. Okay, here we used to consider the class interval, there we used to use the class mark. So for this same data we can find the frequency polygon very easily. Okay, next is it correct to conclude that maximum number of leaves are 153 millimeter long? You can see this class 145 to 153.53 consists the most leaf, right? But we can't say that all leaves are 153, right? So answer is no. The class interval 144.5 to 153.5 consists maximum number of leaves 12, but that does not mean that maximum leaves are from 153.5 meter long. Okay. Okay, fifth question is, the following table gives the lifetimes of 400 neon lamp. You can see there, this question I discussed in live class also. You can see lifetime of the bulbs given here, 300 to 400, 400 to 500 up to 1000. Okay, and number of lamps are given. We have to represent this data in histogram. So I already made the table here. Okay, lifetime and number of lamps. You can see 300, 400, that is 14, 400 to 556, 500 to 660, like this up to 1000, 900 to 1048. So rule is same. We have to draw x-axis here and y-axis here. In this axis we will write 300, 400, 500 up to 1000. Here I miss one thing. Here we have to draw. Here what we have to draw? This line, this sign, right? I told this sign. What is this sign? This sign denote there is a huge gap between 0 to 300. So we are doing this gap in just between. Okay. Now in this here we can see the frequency are 14 and highest is 86. So in this y-axis I took 15 lowest and I used to took the gap of 15. So 15, 30, 45, 60, 70, 90. Okay, first is 300 to 400, that is 14. So it let's just less than 15. So 300 to 400 we draw this line, 300 to 400, and we just draw the line. Next is 400 to 500, that is 56. So on the 56 we draw this line and then we draw the line of this. So this is 400 to 50, this is 50, just nearby 60. Last second is 60, I mean third, 500 to 600 is 60. So on 60 I draw the line. Make it sure this line should not be greater than this line. Okay, so for this what you have to do, on 500 draw the point. Okay, on 600 you draw the point, this line of the 60. Okay, and then draw the line to fill the bar. Next is 600 to 700, that is 86. So 86 just less than 90. So we draw this bar here like this. Okay, next 700 to 800, 74, 74 just smaller than the 75. So here we draw the line. Okay, this is the 74 bar. 800 to 900, 60 to 62 is just greater than 60. So just greater than 60 is this bar. Last 900 to 6000, that is 48, that is just greater than 45. So we drew this bar like this. Okay, so our histogram is complete. Next, second question was, how many lamps have a lifetime more than 700 hours? You can see from the graph, this is 700 and these are the bulbs which are lifetimes hours is greater than 700. You can, from the table also you can see this three category are more than 700 hours. Okay, so number of balls have a lifetime more than 700 hours, that is 74 plus 62 plus 48. 74 plus 62 plus 40, that is 184. That's our answer.